Well, hello, everyone. Today's topic is about oxidative stress. Now, this is a biological process that happens in the body. And if it's left unmodulated and regulated, it causes many of the symptoms that we see today. So let me show you some of the symptoms first before I dive into defining the pathology of it. So from the skin level, oxidative stress is responsible for wrinkles, dryness, early aging, acne, and such. And the reason for that is because oxidative stress and free radicals, that accumulation in the body, breaks down collagen that is responsible for skin elasticity. So it mainly attacks the protein and the fiber that is made of collagen. And if we're looking at the body as a whole, we see that oxidative stress pretty much promotes most of the conditions that we are familiar with today. Neurodegenerative conditions such as Alzheimer, Parkinson, ALS are driven by oxidative stress. It touches the heart, the kidneys, the joints, lungs, and this slide here is worth pausing the video for and just going over, just so you get an idea of the damage that oxidative stress causes. Now let's see what it is. What is this oxidative stress and free radicals? Oxidative stress happens when there is an imbalance between free radicals and antioxidants. So antioxidants fights off free radicals and oxidants. So when the body doesn't have a balance, we have oxidative stress. When we have oxidative stress, we have cellular damage. We may have DNA damage. DNA damage causes DNA mutation, and DNA mutation is a breeding ground, as we know, for cancer. So why are these free radicals unstable? I'm going to go over the instability of these by showing this slide here so I can go step by step on why they're unstable, and if they're left unchecked and if they're not neutralized, then we have a cascade of damage from a cellular level in the body. So in red, you could see that this is a damaging free radical, and simply because it has an unpaired electron. Now, any molecule in chemistry, we know that any molecule that has an unpaired electron is highly reactive and unstable. And because of that instability, it goes on and tries to stabilize itself by all means necessary. And that means stealing electrons from its neighbors. It could be DNA, it could be cell membrane, it could be a protein, an amino acid, it could be anything that is stable, causing it instability. And that cascade of reaction is what causes oxidative stress. Now, how do we neutralize this? How do we stop this from happening? Now, the body enzymatically produces antioxidants. And these antioxidants donate electrons to these free radicals to stabilize them. So when you look at antioxidants like glutathione, for example, it donates an electron to these free radicals and it recycles itself. So it doesn't become a free radical itself. So this is very important to note that we have enzymes like peroxide dismutate. That is an enzyme that is endogenously produced by the body that neutralize these free radicals. Now, what happens if we don't have enough of it? If we don't have enough of it, that we are overtaken by these free radicals, by these ROSs, or reactive oxygenated species, and we cause damage to DNA, protein, amino acid, and the list goes on. So very important to have enough antioxidants endogenously via enzymes or exogenously via foods such as vitamin C, E, and other antioxidants. So here there's a visual of the body behaves in similar fashion as this piece of vegetable. If it's attacked by free radical, eventually it becomes a victim of oxidation and it becomes damaged. Now, the cell, if attacked by antioxidants and it doesn't have enough protection from oxidants, then we have cellular damage, DNA damage, lipid damage, protein damage, and mitochondria damage that is responsible for energy. So this slide here shows you that the body is constantly going to oxidation and repair. But the problem is when we have more oxidation than repair, then it will show either at the joint level or neurologically, or it's going to have some kind of a negative impact on us. So it's very important to have enough antioxidants in the body. We're going to talk about some of the sources that we can make sure that we have enough of that in our bodies so we're not running a deficit. So we have essential versus non-essential. Essential means we must get them from food. Non-essential means that the body can produce on its own. So things like vitamin C, E, and A, we must get from food. And I have a list of food here, the food sources that you can get them from. So you can pause this video and go over it, and it will be beneficial. But then we have cofactors. Cofactors are things like zinc, copper, magnesium. These are cofactors that help the body produce endogenously enzymes as antioxidants. So the best thing to do is we have enough of these minerals that serve as a precursor to these enzymes such as superoxide dismutase. So the body prioritizes enzymes over exogenous antioxidants. So this is why we got to look at all this whole picture as a whole, as a network, and not just individually. And we can't just pick on one nutrient. We got to look at the network of nutrients. We got to look at exogenous versus endogenous enzymes versus essentials, so we can understand the full picture and make sure that we have the right capacity, right amount of antioxidants. So, and here I talk about the enzymatic antioxidants endogenous made by the body and the importance of having enough cofactors. And what I'm talking about is the minerals that we can get from food, such as zinc, copper, selenium, magnesium. All of these are cofactors for antioxidant enzymes. Then the non-enzymatic antioxidants, such as the stuff that we get from food, non-essential or essential, vitamin C, E, CoQ10, polyphenols, flavonoids, all of that stuff we can get from food. Now, the reason why the body prioritizes enzymes over external sources, and simply because the internal sources are recyclable. Now, you can use them over and over and over, but the non-enzymatic exogenous form of antioxidants are not recyclable, meaning you have to replenish the body on a daily basis. So the biomarker that I like to measure the body's total antioxidant capacity is called TAC. And this measures how well the body's antioxidant system can neutralize free radicals before they damage us. So I don't like to pick on one or two nutrients at a time like some companies do, but what you can do is get an overall picture on how your network, your mesh of network is working for you in fighting these oxidants. And that biomarker, once again, is called the TAC. Okay, and that's pretty much it. And I got references here where I got all this information from. And as always, folks, if you have any questions, drop them in the comment section. I'll be more than happy to address them for you. And thank you so much, and goodbye.